Here are the answers for the May 2019 Higher Tier Paper 1. This is a show that question, so you've got to put all your working and treat it as if it was a non-calculated question. So how many thirds are there in 4? Well, there's 3 thirds in 1. So there must be 12 thirds in 4, plus the extra 2 thirds, so that's 14 thirds. How many ninths are there in 1? Well, a whole 1 would be 9 ninths, plus an extra ninth makes that 10 ninths. And from there on, it's a straightforward, simple fractions question. Turn the divide into a multiply and flip the second fraction. So a distance time graph. Yours will be drawn with a ruler, unlike my second diagonal line that's a bit wobbly. So she starts off going to her friend's house, then she stops for a few minutes, and then they continue to the park. Okay. Is she going faster or slower before or after? Well, on a distance time graph, the gradient or the steepness of the line tells you about the speed. So there's a steeper line here, so she's going faster in this section before she met her friend. She stayed at the park for 45 minutes, so I can see that there are 4 little squares making up an hour, so each little square must be 15 minutes. So she stayed at the park for 45 minutes, so that's 3 lots of 15 minutes, 3 little squares. Then she came back at 16 kilometers per hour. And I can see from the graph that the park is 24 kilometers away from her home. So if I'm traveling at 16 kilometers an hour, 16 kilometers in 1 hour means I'm going to do 24 kilometers in 1.5 hours. It's going to take me 1.5 hours to get home, and 1.5 hours, if each little square is 15 minutes, 1.5 hours is going to be 6 little squares, so she's going to be home then. So join them up with a straight line because she's travelling at a constant speed. So work out the average cycling speed for the whole time that she was pedalling, not including the rest stops. Okay, so on the way out, I know that that distance and that distance added up to 24 kilometers. And I know that she took an hour to do this part of it. And she took 1, 2, 3 little squares, so 45 minutes to do that part of it. So on the way out, she travelled 24 kilometers in 1 3/4 hours. On the way back, she travelled 24 kilometers in 1.5 hours. So in total, she's travelled 48 kilometers in 2.25 hours. So her average speed was 21.3 kilometers per hour. When you're dividing powers, you subtract them, so 9 take away 5 gives me e to the 4. A power to a power, you multiply them, so y squared to the power 8 is y to the 16. Multiplying out brackets, so FOIL, first times first, outside times outside, inside times inside, last times last gives us this, and then just tidy up. Factorise fully, that means take as much outside of the bracket as is possible. What's the biggest thing that divides into 16 and also divides into 20? Well, that's a 4. What's the biggest thing that divides into c to the 4 and also divides into c? So that's just 1c. And the biggest thing that divides into p squared and also divides into p cubed is a p squared. put these values into your calculator to work out this formula. That should be the table you get. Then can you plot the graph? Now notice that as usual they've tried to trick you by using a different scale on the x-axis and the y-axis. So 2 squares makes up 1 unit on the x-axis, whereas 1 big square makes up 1 unit on the y-axis. So plot your graph, being careful of the scale. Make sure you get all the points as accurately as you can. Join the graph up with a smooth curve which must go through every one of your points. So she's got a dice that gives her probabilities like this. Well, the first thing you learn about probabilities is they must add up to 1. So you know that all these probabilities have to add up to 1. So that gives me this equation here, which when I solve it tells me that x must be 0.07. Now we know what the probabilities of each individual score on the dice is, so these numbers, we can work out the probability of getting an even number. Okay, so we're interested in what's the probability of getting a 2 or a 4 or a 6. So the probability of getting an even number is 0.46. So if I throw the dice 200 times, 200 times 0.46 tells me that 92 of them would probably come up with an even number on average. You need to know the mass, density, volume triangle. It's not given on the formula sheet. They tell you the density, so we know this part of the triangle. We can work out the volume, because volume of a cuboid is just length times height times depth. So the volume of the cuboid would be 5 times 8 times 12. And using our triangle here, we can tell that mass would be density times volume. So that's density times volume, 336 grams. Write as an ordinary number, so multiply it by 10 6 times. Write it in standard form. You've got to move the decimal point 3 times. Type this into your calculator. Make sure that you put brackets in the right places to get it to do what you think you want it to do. The value of the boat is going down by 8% per year. That means at the end of each year you've got 92% of what you used to have left. It's happening for 3 years, so you're going to do it 3 times. So to the power of 3. So 170,000 times 0.92 to the power of 3 gives us that. Answer correct to the nearest dollar. So for the last mark, I would round this 6 up to a 7 because of those decimal points. So we've got a right-angled triangle and a semicircle. And we've got to work out the area. So the first thing I'm going to do is look at this right-angled triangle. Right-angled triangle automatically tells me 2 things. It's either going to be something to do with Pythagoras or something to do with SOHCAHTOA. So in this case there are no angles involved, so it's a Pythagoras question. And if I do Pythagoras on that triangle, it tells me that the length all the way across from A to C is 8.48. So therefore the radius of that triangle, half the way across, would be 4.24. So now I know that that length is 4.24. So I can work out the area. The area of a triangle is a half base times height, so half 6 times 6, that gives me 18. The area of a semicircle, well, a whole circle would be pi r squared. So a semicircle is a half of pi r squared, and we know what r is because we've just worked it out. So work out those 2 bits individually and then add them together. So we don't know what number A is, but we know it breaks down like that when we write it as the product of its prime factors, and I want to do 8 lots of it. So 8 lots of A is the same as 8 lots of whatever this lot comes to. And if I'm writing it as its prime factors, I can change the 8 into its prime factors, and 8 is 2 cubed. So I've got 2 cubed times this lot. Now you know that when you times a number to a power, so x to the a times x to the b, what we do is we add the powers, x to the a plus b. So when I multiply the 2 cubed by the 2 to the n, I add the powers, n plus 3. Nothing else changes because I haven't got any 3's multiplying into this bracket to add to that one, and I haven't got any 5's multiplying out into it. So there's my final answer. Bounds question. So the word integer means a whole number, except you're allowed to be positive or negative if you're an integer. So 6 to the nearest whole number has got to be between 5.5 and 6.5. 15 to the nearest 5 has got to be between 12.5 and 17.5. Remember, imagine your imaginary ruler is marked out in units of 5. So you've got 15, 20 is the next 5 up, 10 is the next 5 down. Where would you stop rounding one way and start rounding the other way? So that's 12.5 and 17.5. So those are your upper and lower bounds. What's the biggest answer I could get for B takeaway? A, well, if I want the result to be as big as possible, I want to start off with the biggest number possible and subtract the smallest number possible from it. So I get 12 there. Okay, so straightforward factorization of a complex quadratic. Either you've learned how to do this or you haven't. So multiply the two end numbers. Need two numbers that times to give 12 and add to give -7. So that's going to be -3 and -4. 2 divided by -3 doesn't cancel, so there's my first bracket. 2 divided by -4 does cancel, so there's my second bracket. That's it, 2 marks. A fairly tricky equation. So first thing is that I don't like equations on 2 lines, so I'm going to take the 3, move it to the other side and make it a multiply. And then all of a sudden this equation has become a lot simpler. Multiply out the brackets, move everything involving an m to one side, move everything else to the other side. M is 1.2. Again, either you've learned this or you haven't. So the fourth root of something is that something to the power of a quarter. And from there on, you know that when you divide in powers, you subtract the bottom power from the top power. So the y on the bottom is really y to the power 1. 1/4, subtract 1, gives me -3/4 as my final power.